Welcome to your custom deep dive. Today, we are looking at a single, highly technical product page from HDTVSupply. It's for a piece of hardware called the Smart-AVI FDX-3000-PRO-RX-S.
Yeah, it's a bit of a mouthful, but the tech inside is, like, wild.
Right, okay, let's unpack this. On paper, this is basically a receiver. It takes digital video, audio, and USB keyboard and mice signals and, well, extends them.
Yeah.
But the scale is what's crazy.
Oh, absolutely. The scale is the whole point here.
I mean, it's this compact box weighing under 1.5 pounds, right?
Yeah.
And it can receive a 1080p full HD video feed and real-time mouse inputs from up to 10 kilometers away.
That's 6.2 miles for anyone counting.
Exactly. 6.2 miles using single-mode fiber optic cable, or about 425 meters if you're using multi-mode fiber.
Which is just an enormous distance to maintain physical control over a machine.
It really is. To put that into perspective, it's like having your actual computer tower sitting in a downtown office building while you are seamlessly using the monitor and mouse from a house way out in the suburbs.
Yeah, with zero lag.
Right, zero lag. But wait, looking at the specs, it says it pushes 6.75 gigabits per second of data. Isn't that complete overkill just to move a mouse and type on a keyboard?
Well, if it were just text, absolutely. But it's pushing uncompressed 1080p video right alongside that real-time control.
Oh, I see. So the video is the heavy lifter there.
Exactly. Anytime you compress video to save bandwidth, you introduce processing lag. In a hazardous environment, say you're remote controlling a robotic arm, dismantling an explosive even a millisecond of lag from video compression could be catastrophic.
Wow, yeah, that makes total sense. So it has to be uncompressed.
Right, it has to be, which requires massive bandwidth.
Which explains why you can't just use, standard cables for this kind of setup.
What's fascinating here is the physical limitation of traditional copper wires. As electrical signals travel down copper, they hit electrical resistance.
They just lose power, right?
Yeah, the signal degrades or attenuates very quickly. You simply can't run an HDMI cable 6 miles. Fiber optics bypasses completely by converting the data into rapid pulses of light and shooting it down a microscopic glass tube.
So what does this all mean for the user? I saw the retail price on this box is about $850.
Yeah, it's definitely not cheap.
Right. So if fiber just lets us send a signal 6 miles, why pay that when you could just connect the machine to the internet and control it remotely that way? I mean, there has to be a catch.
There is, and it comes down to absolute security. If we connect this to the bigger picture, the internet is inherently public and vulnerable to cyber attacks.
Oh, for sure.
But a fiber optic line is a closed loop. And unlike traditional copper wires, which leak electromagnetic fields that can be picked up by nearby antennas, light doesn't emit a radio frequency.
Hold on. So you literally cannot tap into a fiber optic cable remotely to steal the signal. It's just light trapped in glass.
Correct. A bad actor would have to physically cut the glass tube to intercept the light, which instantly breaks the connection and alerts the system. It's practically immune to interception.
Wow. Here's where it gets really interesting for me, though. Looking at the spec sheet, I saw it was listed as TAA compliant, which I had to look up.
Right, the Trade Agreements Act.
Exactly. For you listening, that basically means it's legally approved for U.S. government use, which suddenly explains that $850 price tag.
It definitely puts it into perspective.
But then I saw it uses RS-232 serial control that is strictly unidirectional. I mean, I haven't heard of an RS-232 port since the 1990s. Why is a modern, secure, military-grade device using such an ancient standard?
Because its simplicity is its greatest defense. Modern USB ports are highly complex. They constantly talk back and forth, which leaves them open to software exploits.
Oh, like they're too smart for their own good.
Exactly. RS-232 is incredibly basic. When the spec sheet says unidirectional, it means data is only allowed to flow one way. In high-security systems, they achieve this by physically removing the receive pin from the port.
Wait, really? So even if a hacker somehow got physical access to the monitor end, the data literally, physically, cannot travel backwards into the control system?
Precisely. That is why this device is purpose-built for government facilities, military bases, or massive factory floors. Places where heavy machinery might disrupt copper cables and bad actors might try to compromise the network.
It's incredible. I mean, we look at this dense list of specs and just see a gray box, but it's actually the invisible infrastructure, prioritizing uncompromised security and extreme distance above everything else.
It really is. And this raises an important question for you to ponder. If we can achieve completely secure, real-time physical control of the machine from 6 miles away using a sealed beam of light instead of the public internet, how might this reshape the future of remote work for hazardous, classified, or hyper-secure industries?